Good morning, students. Welcome to the class of Technomathics. So today we'll be taking some more questions from calculus. Okay, and basically from differentiation. Okay, so here we are taking the two questions from the implicit functions. That is, the first question is that if x cube plus y cube, if this is given to you, if x cube plus y cube is equal to sine x plus y, right? If this is given to you, then we need to find the dy by dx. Okay, so here to find dy by dx, what we will do, we will simply differentiate the LHS, right, and even the RHS, right. So how we will be doing it, you can see, just apply d by dx of at LHS and RHS, then it will be looking like d by dx of x cube plus y cube is equal to d by dx of sine x plus y, right. Hope students is visible to you, right. Now you can see this d by dx of x cube plus y cube can be written as d by dx of x cube plus d by dx of y cube, right. And into the RHS we have d by dx of sine x plus y, but here you can see it's the sine of x plus y is given to you, and here we are differentiating with respect to x, so that will not happen. So that's why what we will do, we will simply just into the denominator, instead of dx, write dx plus y. Why? Because sine of x plus y is given to you, right. So this will be d by dx plus y of what? Of sine x plus y, right. So here you can see this x plus y, sine of x plus y, and we are differentiating with respect to x plus y. So this can happen, right. Now this will happen. Since we have inserted this, we need to just, this is into the denominator, so we need to insert d of x plus y into the numerator also, so that this denominator and this numerator will be cancelled out. And here we have already d of x, so d of x will be coming here, right. I hope this is right. We already just discussed this such question of implicit function differentiation into the study session, right. Now quickly coming to the next step, d by dx of x cube will be what? X to the power n will be n x power n minus 1, so it will be 3x square, right. 3x square plus, here again you can see differentiation of y cube should be happening, is happening with respect to x, so which will not happen. So again what we will do, we can differentiate the function of y cube with respect to y only. So this can be happen with respect to y only, right, this y, and this y is inserted into the denominator, that's why it can be inserted into the numerator also, so that numerator and denominator will be cancelled out, and we have here dx, right. And into the RHS we have d by dx plus y of sine x plus y. We already did this into the earlier stage, so here I am mentioning it's y and y, so it's same, right. Now sine of x plus y, what is the differentiation of d by dx of sine x? It's cos x, right. So simply write over here cos of x, so instead of x it's x plus y, so it will be cos x plus y. We simply differentiated sin x plus y with respect to x plus y, right? So that's why we inserted, right? Anyway, this multiplied with d by dx of x plus y. So this will be coming as, let me write into the second line, d by dx of x plus d by dx of y, right? Now coming to the third step, 3x square will be as it is, plus, now we can differentiate this y cube because we already inserted dy into the denominator and numerator of LHS with this term, right? So dy cube will give you what? X y to the power n, n n y n minus 1. So it will be 3y square, right? 3y square for this. Got it? But we have additional dy by dx. This is left. This dy by dx is left. So just multiply dy by dx. I could not say multiply, it's already there from the beginning, from the previous step. And into the RHS, we have cos x plus y, right? And d by dx of x will be what? It's 1, right? And dy by dx will be as it is, right? So we are achieved, we are just arrived at this step. Okay, here you can see dy by dx is here also and dy by dx is here also. So what we will do, we'll just bring the dy by dx terms into the LHS. So it will be coming as 3y square into dy by dx, which is already there into the LHS, plus when this dy by dx will be coming with this cos x plus y, because this is multiplying over here, mind it. So this will be multiplied with one also and this one also, dy by dx also. So this will give you cos of x plus y into dy by dx, right, is equal to this cos of x plus y is already there, right? So write it, cos of x plus y, then this 3x square will be going to the RHS, right? So this will be minus 3x square. So here you can see we have all the terms with only dy by dx. Okay, so dy by dx can be taken as common over here. So what we will do, we will just take the common dy by dx, and we have with us 3y square minus cos of x plus y, right? Basically this can be a curly bracket, so I'm not mentioning it, is equal to cos x plus y, here cos x plus y minus 3x square, right? So this will give you the value of dy by dx. We have almost arrived at our solution. So the value of dy by dx is coming as, into the RHS we have cos x plus y minus 3x square, right? So write cos x plus y minus 3x square, and into the denominator we have what? This one will be going into the denominator. So this will be 3y square minus cos of x plus y, right? So students, in this way we have solved this question, and the value of dy by dx is calculated, and that is equal to cos of x plus y minus 3x square divided by 3y square minus cos of x plus y. So students, we have solved this question. Okay, so let us go forward and take the second question. The second question which is in front of us, which I have mentioned into the today's live session, is that if x cos y, if is given that x times cos y, right, this is equal to sine of x plus y, this is given, then what is the value of dy by dx? Okay, so into this question, as we did, just apply just apply just differentiate the LHS and RHS with respect to x, right, here and here also, right. When this will happen, you can see two terms in product, x into cos y. What will happen? First we will write the first term, right, then differentiate the second one plus the second term and differentiate the first one. So in this way here, what we will do, just take cos y out of this differentiation multiplied with d by dx of x, right, this x here. Now plus, now x will be kept apart, so x into d by dx of what, cos y, this cos y, right. So the LHS will be looking like this, and into the RHS we have d by dx of sine x plus y. So as we did earlier, since this is x plus y and this we need to differentiate with respect to x, so this will not happen. We can differentiate sine x plus y with respect to x plus y only, right. So that's why into the RHS we have to do some changes. Just write sine x plus y as it is d of sine x plus y, but this can be differentiated with respect to x plus y only. So just insert this one, dx plus y, right, and since this is inserted into the denominator, this need to be compensated from inserting into the numerator also here, so that this and this will be cancelled out, right, and we have dx as earlier, this one dx, right. Now the LHS will be cos y, and d by dx of x will be what, 1 plus x time d by dx of cos y, so it will be x into d by dx of cos y. What is d by dx of cos y? Tell me. This is minus sin y, right? Simple formula. Now into the RHS we have d by dx of sin x plus y. So what this will give? D by dx of sin x plus y will give you, tell me, cos x plus y, right? So this will give you cos x plus y, right? For this multiplied with d by dx of x plus d by dx of y. This is the same thing which is here. Now into the LHS, cos y multiplied with 1. So what we did over here, I hope you understand. We have inserted d of x plus y into the denominator over here and here into the numerator, right? So the LHS will be cos y minus x sin y, and into the RHS we have cos x plus y multiplied with d by dx of x will be 1 plus dy by dx will be as it is, right? Now what we will do, here you can see x times d by dx of cos y was happening. Okay, so we did it for cos y over here and it's sin y, but since cos y differentiation is was happening with dx, so this will not happen. So that's why we have inserted here dy by dy as we did for x plus y over here, right? So let me shift a little. Yeah, here dy by dy. So the differentiation of cos y happened with dy only. So this will be, this was like this, cos y. So d by dy of cos y. So that was minus sin y. Okay, and here we have dy by dx was left. So that's why here dy by dx was left, that need to be added, right? We simply added this dy by dx. So this with minus x sin y, another term dy by dx is here, right? So let's say dy by dx, after that it's equal to, so you can see dy by dx here into the RHS also and LHS also. So what we will do, we will bring this dy by dx into one side of the equation. Okay, so it's minus, just push it to the RHS. So into the RHS, so first just write the LHS, this cos y, and this cos x plus y multiplied with 1 going into the LHS, this will be minus cos x plus y, right? And into the RHS we have cos x plus, just take dy by dx as common, and we have cos x plus y, this multiplied with this, right? So I'm writing cos x plus y, right? Now since this was taken as common, so common can be taken into the next step. Just push this minus x sin y dy by dx to the RHS. So this will give you plus dy by dx of x sin y, x sin y. Am I right? Now you can see dy by dx can be taken as common into the RHS. So from here, when dy by dx, when dy by dx is taken common into the RHS, we have cos x plus y plus x sin y. Am I right? This is cos x plus y plus x sin y. So that is into the, that is of the RHS, this term with RHS. You can see here dy by dx is taken as common, right? And into the LHS we have already cos y minus cos x plus y. Just simply write it, cos y minus cos x plus y, right? So cos y minus cos x plus y. So we have almost reached to the last step of the solution. So here we can see if dy by dx is kept into the RHS, then into the LHS we have cos y minus cos x plus y. Simply write it, cos y minus cos x plus y divided by, the fraction will be there, and here cos x plus y plus x sin y. So just write y term first, just to make it a similar terms together like that. So x sin y I'm just turning the term x sin y was into the second term, so I'm writing it first. That's it. So don't get confused that I'm inserting something else. Plus cos x plus y. So students, you can see we have differentiated the value of y, this one, the function x cos y equal to sin x plus y, and we have reached to the solution that dy by dx is calculated, and that is equal to you can see here cos y minus cos x plus y divided by x sin y plus cos x plus y, and this is the value of this dy by dx. And students, in this way we have solved this question also. So I hope you liked the today's session, students. Hi Raj Thapa, hello, how are you? Hello. Yeah, tell me any step where you feel some clearance, I doubt clearance, let me know. Hope you are doing good. In which class are you? Or doing some preparations? Hello friend. Yes. Yeah, we have taken two questions for today. I just explained each and every step and try to break each and every step very, very minutely. Okay. So in each of the step or anywhere, if you find any doubt, let me know. I will help you out. Okay. So very thankful to you all for being connected with me, and let's have this journey, and I will wish to have a long association. And let me know for any doubts, you can put up into the chat box. I will there to help you. Okay. Yeah, for any kind of, yeah, in maths and physics. Yes, yes. Yeah. So students, thank you so much for being connected, and keep on learning, happy learning. And yeah, for any specific question or for any specific doubt, you can just write to me. I am very happy to help you. Okay. Be connected. So with this, I think we can wind up this session, not taking that much of time. And thank you so much. Happy learning. Bye bye. Thank you so much, students. I think with this we can wind up today's session. So we have taken two questions for today. So let me quickly wind it up. This was the question given to you. As into the last, I was reviewing the steps very quickly. So let me do it for the second question first. So here it was given that x cos y is equal to sin x plus y. We need to differentiate this. We need to find the value of dy by dx. So what we did, we applied d by dx into the LHS and RS both. When we applied it, you can see here two terms are there, x into cos y. So we applied the formula, a into b was there, right? So we just differentiated the first term. Okay. So and keeping cos y as outside of this, so that's why cos y is taken outside and d by dx of x happens here. That's why I am showing this with arrow. Plus x times, that means this x is kept outside and this cos y is differentiated, but you can see cos y could not be differentiated with respect to x, so that's why we inserted dy by di into the numerator and denominator over here, right? So that's why for if d by dy of cos y is taken, then this was minus sin y, and dy by dx was left, so that I mentioned over here. And similarly it happened to the RHS also, because sin x plus y could not be differentiated with respect to dx. So that's why dx plus y you can see here and dx plus y you can see here, that is inserted into the numerator and denominator, so that this when you cancel this you will remain with the same thing as into the previous step, right? So that's why what is the benefit of inserting dx plus y? We then only, unless and until we insert it, we would not be able to differentiate sin x plus y, right? So here you can see Sin x plus y is differentiated because it is differentiated with respect to x plus y. So that's why we get minus sin, you can see cos x plus y here. Sin x plus y differentiated with respect to x plus y, and we get cos x plus y. And here also, since dx plus y was left, so that's why dx plus y is differentiated with respect to x. So two functions in addition, so both are splitted over here. So dy dx of x and dy dx of y over here, right? So that's why into the LHS we have cos y minus x sin y dy by dx, and into the RHS we have cos x plus y into d by dx of x will be 1, and d by dx of as it is. And when we take dy by dx as a common into the one side of the equation, we get cos y minus cos x plus y equal to dy by dx into cos x plus y plus x sin y. So with this, when dy by dx is kept into the one side of the equation, we get the value of dy by dx as cos y minus cos x plus y, which was already there into the numerator, divided by this term. So this term is going into the denominator, that is x sin y. Here is x sin y plus cos x plus y, cos x plus y. So the second question which I explained to you. Yeah, Raj. Yes, yes. And what was the first question? This was the first question which we have taken today. Okay. Since we have been given with x cube plus y cube equal to sin x plus y, right? And we need to find the dy by dx. This one need to be calculated. This one. What is the value of dy by dx? So what we did, we just differentiated both the LHS and RHS with respect to x. You can see here. But here, as we did into the second question, this was the first question. Here also we did the same thing. Differentiation of any x, the variable in form of x, can be done directly, because you can see it is differentiated with respect to x. But here y could not be differentiated with respect to x. So that's why this was the difference. So that's why y dy by dy inserted into the numerator and denominator over here. What is the benefit of insertion of dy by dy? You can see it will be cancelled out. But the benefit of insertion is that when unless and until dy differentiation will with respect to y will be mentioned, then this y cube we will not be able to differentiate this. Okay, so that's why d by dy of y cube will happen, because the function is into the variable y, and this can be differentiated only when we are going to differentiate it with respect to y. So that's why here it is done, and we get 3y square for this. I am just talking for the LHS only. Okay, so 3y square, and here we are left with dy by dx. Similarly, when you go to the RHS, it's sin x plus y. This can also be sine of x. If it would be sine of x only, then we would be easily differentiate with respect to x. But here we are not going to, there is no help. We are not be able to differentiate this. Okay, because it's x plus y, you can see, and x plus y could not be differentiated with respect to x, right? So what we need to do, we need to insert dx plus y as we did over here into the denominator, and dx plus y here into the numerator, so that once you cancel out, it will be as it is. It will be as it is, d of sin x plus y by dx. But this is inserted because then only you would be able to differentiate sin x plus y. So this will give you differentiation of sin x plus y, differentiation of the given function with respect to x plus y will give you the differentiation of sine of that function. So that will give you cos x plus y, right here. D by d of x plus y of sin x plus y will give you cos x plus y, and into the denominator, into the multiplication, we have d by dx of x plus y, this one. So this will give you d by dx of x plus d by dx of y. Here you can see x and y separate. So when cos x plus y is taken as common, as already into the previous step, then into the bracket d by dx of x will give you 1, and d by dx of y will give you dy by dx. right? Here also you can see dy by dx is already present over here into the LHS. So what we did, we just bring the dy by dx terms together into the LHS. So here 3y square dy by dx is this one, right? And this term dy by dx into cos x plus y, the second term of the RHS, just brought to the LHS here, cos x plus y into dy by dx, right? What is the benefit of bringing it over here? So that dy by dx, you can see here, dy by dx is the term which is common into both, right? And into the RHS we have cos x plus y into 1, so that is cos x plus y, and 3x square from LHS will be coming into the RHS, so it will be coming at minus 3x square, right? So finally dy by dx is taken as common, and we are left with 3y square minus cos x plus y, right? And this is equal to cos x plus y minus 3x square into the RHS. So simply we just put dy by dx as a separate into the LHS, and we get the value of dy by dx as cos x plus y minus 3x square, which is already there into the RHS. So that will be coming into the numerator, divided by the coefficient of dy by dx, the terms associated with dy by dx into the LHS, which will be going to the denominator. So this will be 3y square minus cos x plus y, right, this way. So 3y square minus cos x plus y will be coming into the denominator of the RHS. So in this way we have solved the value of dy by dx, and we get the value of dy by dx, students. So thank you so much for watching, students. Just keep on learning. Happy learning. Bye bye. Take care. Be connected. See you.